So in this video, we're going to look at example 1, where we rewrite a rational function to identify asymptotes. So they want us to rewrite g of x equals 4x over x minus 3 using long division, and how is the quotient related to the reciprocal function f of x equals 1 over x, and then sketch that graph. All right, so the first thing we want to do is we want to use long division. So we're going to take our function of 4x over x minus 3, and we're going to write that as x minus 3 divided into 4x. So the first thing we want to do here, remember, is divide x into 4x. So x into 4x would be 4. I'm going to write that up here. And then we do 4 times x minus 3. So that would be 4x, and then 4 times negative 3 is minus 12. And then we want to subtract those. You can kind of remember that there's a 0 here. So 4x minus 4x would cancel out, and then 0 minus negative 12 would give us a 12. Now this, we want to remember, is our remainder. And what that means is I can rewrite this expression as 4 plus 12 over x minus 3. So this is my g of x. All right, so g of x can be rewritten as 4 plus 12 over x minus 3. Now, does that help us? In the form it's in, maybe that might be a little tricky, might be confusing, but this does help us because we can now rewrite this in a form that'll help us, and that'll be in the form, let's say g of x. We'll stick with g of x equals a over x minus h plus k. And this is what we covered in last section, where this tells us vertical asymptotes with shifts left and right and things like that. So when we rewrite this, we now have g of x is equal to 12 over x minus 3 plus 4. Right? So I was just able to move that 4 to as the second term, rather in the beginning, and that kind of puts it in place of k. So now I have this in this form, and what I want to look at, let me just get rid of these here so we don't confuse ourselves. What I want to look at is this minus 3, which is my minus h, and this plus 4, which is my plus k. And we'll get to the a value in a minute. We haven't covered that yet, but we will get there. I'll mention that towards the end. So what this minus 3 tells me that's happened is that there's a shift to the right. All right, so my graph, if we were at the origin, we're going to wind up shifted right 3 places. So 1, 2, we'll say about here. All right, so we'll keep that in mind. And then this plus 4 tells me that there is a shift up. So we're going to go up 1, 2, 3, 4. So again, somewhere in that range. So I'm looking at somewhere over here as this center where maybe some asymptotes will cross. The next part of this is we want to find the actual asymptotes, right? So with these asymptotes, first thing we want to look at is potentially a vertical asymptote. And remember, this is kind of backwards. So vertical is going up and down, but since it crosses the x-axis, my vertical asymptote is going to be x equals something. And since we shifted this graph to the right, so this shift right here, my vertical asymptote is going to be x equals something. And in this case, it's going to be that shift right, so it'll be x equals 3. And what I'm going to do is I'm just going to put that asymptote going right through there. So we'll try to keep this as accurate as possible, but it's just a sketch. So I have a vertical asymptote somewhere in that range, again, about at 3. Next, I want to look at the horizontal asymptote, and that was my shift up. And again, this is a little bit kind of tricky, but the horizontal asymptote goes left to right, so it crosses through the y-axis, so it'll be y equals something. And in this case, we shifted up, so it would be y equals 4. And let's highlight that in red, and let's draw that. So again, try to keep this as accurate as possible, but we have an asymptote that goes somewhere around here. Okay, So we now have our vertical asymptote labeled, we have our horizontal asymptote labeled, kind of answering the questions, and now they want us to do a sketch. Now the piece I said I mentioned, this 12, so what this 12 does is it vertically stretches my graph. And you may remember that from the A values. Remember A's were like stretches or compressions? So because A is greater than 1 in this case, it's a 12, it's going to stretch the graph vertically. So it's going to kind of think of it as like being pulled from like north and south, top and bottom. To graph this sketch completely accurately, there's two things you can do. You can use graphing calculator applications or like an actual graphing calculator or something like Desmos, or you could create a chart. For the sake of this video, I'm not going to do either. I'm just going to draw a little bit of a sketch here. I already know what this one looks like. You would not know whether to shade the top left, top right, or bottom left, or sorry, not shade, which section to pick, unless you already saw a graph of this. So I'm just going to draw some kind of sketch here. It's going to look something like this. Again, we're not talking perfectly accurate here, so don't hold me to my exact points on this graph, but will look something like this. It's not always easy to see vertical stretches and compressions with kind of the naked eye looking at them, but you will see them as you use the more of, again, a graphing calculator or Desmos. Whether you zoom in or out, you'll be able to see a little bit more detail to that. Make sure you understand the long division part here, how to rewrite something. All right, this is our kind of our ultimate goal here, is being able to rewrite a function. And then once we rewrite that, that'll give us the vertical and horizontal asymptotes, which will allow us to have a sketch of the graph. But these specific pieces, so the only way, this what's highlighted in pink here, the only way I would know where to put that is if I created an XY chart or I use some kind of graphing application function, whatever it is that you want to call it. You're not going to just know looking right at the function. So you will need to use some kind of outside resource for that, or you create an XY chart. That's it for example 1, and hopefully give the try it problems a go and see how you do on those.